Alright, so this is the counting elements and atoms. We are almost done with chemistry unit, so this is the second to the last PowerPoint that you have to do. Make sure you are doing the Cornell notes, so check your previous notes, the periodic table and the atoms. Some of you guys from the periodic table notes did really well. I was very impressed, so make sure that you keep up with that Cornell style. Make sure you're highlighting and make sure that you're using colored pens. Okay, up to you. So you can do both with the highlighting and the colored pens, or you can just do one or the other. This PowerPoint, or this lesson, there's a lot of kind of math involved, so if you're really good at math, this should come easy to you because it's a little bit of like algebra. If you struggle with math a little bit, make sure that you're paying attention and you're writing everything down and checking your answers to see if they are correct. So the essential questions that you need to write down at the top of the page are: how are chemical formulas used to identify substances? And how do chemical formulas determine the number of atoms of each element using subscripts, coefficients, and parentheses? Go ahead, pause here if you are still writing. Alright, so there is no interactive notebook template that I printed out for you guys, so make sure that you write this down. I would write this down in 3 columns because I will be checking this when I am stamping it. One column has elements and compounds, and another column has the number of atoms, and another column has the number of elements. So go ahead and pause here so you can write those columns down. Make sure that you do write all of them down. You don't need to fill in the number of atoms and element information. You're going to do that at the very end. Alright, you're going to do the same thing. You're going to have 4 columns. You're going to fill in some information, so make sure that you leave some space underneath the atoms or the elements. Filling in the space is you're gonna figure out what's an atom, what's an element, what's a compound, which one of these has a subscript, which one of these has coefficients, which one of these has parentheses. So that's the information that you're going to write down in the space below these atoms and elements and compounds. Go ahead, pause here. Alright, so an element is a chemical that cannot be broken down into another substance. So each unique capital letter represents a different element. So how many elements are in glucose? So this is glucose right here. Again, an element is a unique capital letter, represents a different element in a compound. So for here I have carbon, I have hydrogen, and I have oxygen. So I have 3 elements in glucose. Don't worry about the numbers yet, we're going to get there. Go ahead and pause here if you are still writing. Alright, so an atom is the smallest part of a chemical element. It is found on the periodic table. Combining atoms creates molecules, so make sure that you have that information written down. So this is a molecule of an element. So there are 2 atoms here, if you can't see, but there's kind of together. There are 2 atoms in this element, or in this molecule of an element. And then there are 3 atoms in this molecule of a compound. So this one said compound and this one says elements. That means there's 2 different atoms in this compound. Go ahead and pause here if you're still writing. So an expression which states the number and type of atoms present in a molecule of a substance. So H2 tells you there are 2 atoms of hydrogen, and H2O tells you that there are 2 atoms of hydrogen and 1 atom of oxygen. So you don't see that imaginary 1 there. It's kind of like in math when you have your x plus 2x. How do we know that it's 3x? Well, in the beginning in 6th grade, you all struggled with that a little bit, but you have your imaginary 1. So this is the same thing, except your imaginary 1 is the little subscript, the little number after the element. Go ahead and pause here if you're still writing. How can you tell there's only 1 atom of oxygen in H2O? It is the small number after the element's name. No subscript means there is only 1 atom present. So this is kind of a review of the last slide. The 1 is not needed. The 1's not necessary. The fact that you see the oxygen there, it's not going to be there if it was a 0. So if there wasn't an oxygen there, it would just be H2. There's no point in putting all these letters and all these elements together if they're not actually in the molecule. Go ahead and pause here and go to the next slide. Alright, so now you're going to practice counting. You are doing these set of notes after the quiz, so I don't know if you're going to be able to be talking and working with your partner at this time. Depends if everyone's done or not. If everyone's done, you can work with your partner for this, but if they're not, you're working by yourself. So you're going to count the number of atoms in each formula using the subscript. When you are done and you want to check your answers because you just want to make sure you understand it and you are correct, the answers are going to be in the front. If you're 100% confident, then you don't need to come up. But we're going to do this first one together. So this is copper sulfate. I know that there are 3 elements in copper sulfate. Remember that if there's a lowercase, that does not tell us that that's a different element. That is the copper, the symbol for copper. So for the Cu, there's no letter there, so I know there's 1. For the S, for the sulfur, I know there's 1. And then there's an oxygen, there's 4. So the total is 6. Alright, you're going to do that with the other 5. When you're done, you can move on. Go ahead and pause here. Alright, so now we have subscripts and coefficients. So we just finished with the subscripts. Remember, subscripts are the little number after the element's name. Now we're dealing with coefficients, and you might have heard that term in math before, but the coefficient is the number that's in front of the compound. So it's the big number at the beginning of this formula, and that is called the coefficient. It is involved in counting atoms. It represents the number of molecules for that compound. It is important when balancing equations, which you will not do in 8th grade. So, calculating the number of atoms including the subscripts and coefficients. This formula means that there are 2 sulfuric acid molecules. So if you look at that picture, that's number 1 and that's number 2. So that is basically what it's telling me. There are 2 ways that you could solve for the sulfuric acid. So that first way that you can solve for it is ignore this 2 for a second. Let's figure out how many atoms there are in this formula. So I see that there's 2 hydrogens, 1 sulfur, and 4 oxygens. Oops. Don't know why I did the Q. 4 oxygens. Okay, now I'm going to erase that 2 that I just hid. And I'm going to distribute that 2 and basically multiply that 2 but by all the atoms that I currently have. So I have 2 times 2 equals 4. I have 1 times 2 equals 2. And I have 2 times 4 equals 8. Alright, basic math here. I'm adding down. 8 plus 2, 10. 10 plus 4, 14. 14 atoms. Alright, the other way you can do it is, again, erase that 2 for a second. I'm just getting rid of it. I have 2 hydrogens. I have 1 sulfur and I have 4 oxygens. So my total is 2 plus 1, 3, 3 plus 4, 7. Now I'm going to bring back that 2 and multiply the whole thing by 2. So now I have my 7 total. 2 times 7 is 14. Alright, so there's 2 ways that you can solve for your formula when you're figuring out the number of atoms and there's a coefficient involved. Go ahead and pause here if you're still writing that information down. Alright, so now you're going to practice with counting the total number of atoms in each element in the compound. So you have your coefficients and you have your subscripts. For example, on this first one, we're going to go through it together. I have my Cu. So I have 1, and I have 4. So 1 copper, 1 sulfur, and 4 oxygen. I can add that together. So 1 plus 1 is 2. 2 plus 4 is 6. Multiply the whole thing by 6, and I get 36. Okay, that's the first way I can do it. Or I can distribute that 6 to each element that's in that formula. So 6 times 1, because copper has 1, is 6. 6 times 1, because sulfur has 1, is 6. You're not multiplying anymore, so we're just going to add. And then 6 times 4 is 24. I'm going to write it a little bit bigger here. Alright, working backwards, 24 plus 6 is 30, plus 6 is 36. So again, I showed you 2 different ways. There's 2 different ways to find the answer. Make sure that you're just not being super sloppy like I am with my stylus, sorry. But again, when you're sloppy with your math and stuff, that's where you tend to make errors. You're going to do the remaining 5. If you are confident that you got everything right, you don't need to check. If you think you want to just double check to make sure you're correct, you can. It's at the front. Go ahead and pause here to get this done. All right. Actually, bye. All right, you're going to calculate the number of atoms, including the parentheses. So now we're dealing with the parentheses. This formula means aluminum is bonded to a molecule of sulfur and oxygen. So this 3 is only going to be distributed to what's in the parentheses. It's not going to be distributed to the aluminum. So for this, I have 2 aluminum. I have that 1. I put that 1 there for the sulfur. 1 times 3 is 3, so 3 sulfur. And then 4 times 3 is 12, 12 oxygen. So now I have, adding that all up, 17 atoms total. So make sure that you have that all written down. You can pause here if you're still writing. Alright, now you're going to practice this. So, we're practicing with the subscripts, the coefficient, and the parentheses. So for barium, this first one that we're going to do together, I have 1. Again, that 3 does nothing to that barium. It's not behind it. It's not in the parentheses, so you're not going to multiply that 3, and we're not going to distribute that 3 to the barium. We're only going to distribute that 3 to the nitrogen and to the oxygen. So 1 barium plus 1 nitrogen, but the nitrogen is multiplied by 3. So 3 nitrogen, and then oxygen, there's a 3 there, so we're going to multiply that by 3. 9. 9 plus 1 is 10 plus 3, 13. 13 atoms total for that first one. Alright, you're going to do the remaining 5 on your own. Go ahead and pause here if you're still working. Alright, so now we're going to calculate the number of atoms, including subscripts, coefficients, and parentheses. So this formula means there are 2 molecules of aluminum sulfate. So we have our coefficient. Remember, this is our coefficient. We have our subscripts. And then we have our parentheses. I'm not going to write that out. I'm just going to do parentheses. Oopsies. Alright, it just erased on me, so I'm not going to write that again. Alright. So the best way to take on this problem is before you distribute that 2, since there's 2 molecules, you're going to do the parentheses. So for that sulfur there is 1, so there's 3. And then for that oxygen there's 4, so now there's 12. Alright, so now that I distributed that 3, so the parentheses, I see here that I have 2 aluminum, 3 sulfurs, and 12 oxygens. So there's 2 ways again I can do this problem. Combine all these together, so 2 plus 3 is 5 plus 12 equals 17. And then I can multiply that by 2. And I get 34. Okay, another way I can do it. Two times 2, 4. 2 times 3, 6. 2 times 12, 24. And then I can add that all up. 4 plus 6, 10, plus 24 equals 34. So again, I just showed you 2 different ways you can get the same answer. Either way works. It's just what is easiest for you. If you are still writing, you're going to have to pause here. Alright, so now you're going to practice counting. I will show you that first one. So I have my barium, and I'm only going to show you one way to do it. So for your barium, I have 1. For my nitrogen, I have 3. How I got that 3, remember, I'm distributing the 3 on the outside to what atoms are on the inside. Now I have 3 oxygen, so I'm going to multiply that 3 times 3, and I have 9. Okay, now, again, this is where you can do it either way. I can add them all together and then multiply by 2, or I can distribute that 2 to all of them. I'm going to just distribute that 2. Okay, so 2 times 1, 2. 2 times 3, 6. 2 times 9, 2 times 9, 18. And then you're going to add that all together. And I'm going to get whatever is easier. So 18 plus 2, 20, plus 6, 26. And that's your answer. You're going to solve for the other 5. Again, this is where all of them are combined, so this one does get a little bit more challenging. Double check your answers. The answers are going to be in the front. Go ahead and pause here while you get this written down. Alright, so we made it to the end of the PowerPoint. Can you recognize that chemical formulas are used to identify substances? So all the formulas that you've been seeing today, you've been pulling out the atoms and identifying what elements there are, and that's what you've been doing. Can you also recognize that chemical formulas determine the number of atoms of each element in chemical formulas containing subscripts, coefficients, and parentheses? So we were practicing, we were building, we started with the subscripts, we moved to the coefficients, and then we did the parentheses, and then we combined all of them together. So now we're going to go back to that column that you made. You made three different columns. You had 8 different elements / compounds / formulas. So right now you're going to identify the number of atoms and the number of elements. So remember, atoms is like the total number that you see, and then the elements is the total different elements that are in that compound. So go ahead, get that done, and then you're done with the notes.